Bismillahirrahmanirrahim. In reference to this research paper, if you want to only perform the multiple objective optimization using composite desirability method with equal weights, then the first step will be transformation of your mono optimization results, whether they have been obtained by signal to noise ratio or using any results, but you know that all of them have different optimum levels. So you will have to perform a multi-optimization. So do the normalization of all such responses by using the equations 4 and 5 in this research paper. These are the desirability values for larger the better or higher the better, and lower the better or smaller the better. So using these two criteria, please don't get confused with the top and the bottom one. You will have to use this formula Pij. These are the interval values minus maximum of your response divided by maximum of your response for that column minus minimum of that response. For example, you can do it either based on the original values. These are the values for the surface roughness RA, RQ, RZ, MRR, curve fit, and the dross. So it's up to you. Either use the original values or use the signal to noise ratio. Both will give you the same results. So after that, apply the formula for the normalization. So in order to for the A's, I suggest you people to calculate the maximum value for each of the columns. Select the column. Here we go. Drag it down so you have the maximum values for all of the observations, and then calculate the minimum for all of them, so that it will help you when you are going to apply the formula. I have computed the values based on signal to noise ratio and the original response variable. However, this video is based on the experimental values. So here you can see that the formula has been applied. So B6, it is basically the experimental value minus B6 to B14, the maximum value in this column, divided by minimum B6 to B14, so 192.18, minus maximum B6 to B14, so this is the maximum value, raised to the power 1. So why I have taken 1? Because here you can see it's R. So R is usually taken as 1. So after computing the normalized data, then you will have to compute the weights. So if you are using some technique for the extraction of the weights, it's okay, because I have made a lot of the videos in which I have told you different methods, just like PCA or some other expression for the extraction of the weights. If you're not using any method for the extraction of the weight, then you will be using equal weights criteria. How to compute equal weights? We have 6 different responses. So what you will have to do, you will have to divide, basically the weights are equal to 1 or 100%. There will be 6 criteria. So 1 divided by 6. This will be equal to 0.166. So it means that the weight for all of the responses will be this one. Now, how you do the multi-optimization? So for the multiple optimization, you will have to multiply this RA value with the weight of the RA. Okay, then multiply. So you can see it here in this formula. So J6 multiply P6. J6 is the RA value. Multiply P6, it's the weight. Multiply by again K6. So this is 0.395 normalized value for the RQ. Multiply by its respective weight. That has been depicted in the P7. Then L multiply by P8. So L is 0.373 RZ multiply weight of it. So likewise, I have multiplied all of the values with the respective weights, and then the product of all the values, it will give us the CDF value, desirability values. The desirability here, DJ, WJ, these are the response desirability values. Based on these desirability values, their multiplication will give us the composite desirability, overall desirability. So the overall desirability for the first treatment is 0. Likewise, we have calculated all of them. Let's have a look that here I have multiplied J14, the last cell, with the multiply by its respective weight, then K14, then all of the values that are in the row 14. So this whole row multiply by respective weights and then multiply in the product overall. So I got 0.6677. Now, based on these desirability values, we have to give the ranking. So ranking is quite easy. You will have to use the ranking formula, that rank. Then you will have to select the first cell of the desirability values, then comma. Then you will have to do, here you will have to use the full dollar function. Okay. And then, for example, you can see it here in the ranking number 1. So rank 10, R6 to R14. So this one, this is 1, 2, 3, 4, 5. Fifth treatment is found to be have the highest desirability value. So we can say that in our experiments, the treatment number 5 is found to be the best one. However, in order to get the result for the overall all of the parameters, we have to perform the analysis in the Minitab. So the question may arise, why in Minitab? Let me perform it and I will explain you. So first of all, in the Minitab, make a Taguchi design, DOE, Taguchi, create a Taguchi design, take a 3-level design with 4 number of factors in the design, select L9. After the L9 factors, so here write C, V, S and T. Click OK, and then option nothing to do, click OK, and here we got the design. After that, go to the Excel, select all of these values, paste them there, just right here. These are the CDF values. Then perform the analysis. Now to perform the analysis, go to Stat, DOE, Analyze Taguchi design. Here you will have to select the response. In the option, select larger is the better, because since we have selected the highest desirability value, so we want to maximize it, and we have to find the setting that will maximize our desirability values. When the desirability value is maximum, we will get our desired responses. So we got the result. I'm copying this result and I will paste in Excel to explain you. Here I'm going to paste it. Now, what is depicted by this result? This result is showing that C current has the highest rank, followed by speed, then temperature, and the least by voltage. How we compute this delta rank? Delta rank has been computed by the difference in between the mean of the maximum. For example, at the level 2, we have the maximum mean for C and minimum at level 1. So by taking their difference, we got this delta value. The highest delta corresponds to the rank number 1. After that, what is the fruit of this research work? Select the levels that are associated with the maximum value of the means. For example, for C, the maximum value is at level 2. So C2, V2, S3 and T1. This is our multi-optimization based on the composite desirability method. So that's all for today's video. If you have any question, you can contact me via WhatsApp or my email address.